All right, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1000. Hopefully you guys had a good week. We had a quiz this week, so the main agenda for today is to actually go through the quiz, make sure everyone understands everything. We're all on the same page. Nothing too complicated yet, but we are, I see Ava is outside. That's nice. So jealous. Okay. Nothing too complicated yet, but there are still some important things that we have to make sure that everyone is on board with before we move on. We are going to go through the quiz pretty much, and then I'll just answer if we have time left over, which we probably will. I'll answer whatever questions you guys have later on. So let's actually get to that. I'm actually going to share from a different screen. Okay, Dylan, I'll let you in back when you get back. Oh, there you are. Okay, let's do this. Okay, so hopefully you're seeing my screen right now. Okay, so quiz one. Let's move this over here. Let me keep the chat open so I can see it. Okay, so we should be good. And let's actually get started. So this was quiz one, our first quiz. And I'm pretty much going to be working through it with you guys. So let's actually just jump right in. So question one had a bunch of parts to it. Question one was going through the rules of PEMDAS pretty much, which was one of the important rules that we went over. So let's actually jump into it. And I believe also, can I do this here? Just to make things a little bit more interesting. Do you guys see a poll that I just launched? Let me know your thoughts on problem 1.1. Just have a little class interaction going on here. Okay, so you should see a poll, get your votes in. And again, this is something that you've done before, so I won't give you guys too much time. So get your votes in another 25 seconds or so. Everyone's pretty certain here. Everyone's choosing the same answer. But is it the correct answer? Okay, so 3 people left to vote, but I'm closing voting now. So yeah, like 100% of you are sure that 1.1, the answer is B, 35. Of course, let's actually look at that. So the idea here is we're using PEMDAS. Someone's just coming in, let me let them in. So we're using PEMDAS, which tells you that you should first look for parentheses, then you look for exponentiation. Then the thing that we often forget about PEMDAS is multiplication and division and addition and subtraction have the same priority. We'll get to that later. But yeah, you do things generally in this order. So when we see this, the first thing that we would do is the division. So that part is going to be 0 plus 7 times 5. Then we would do the multiplication, which is just so 35 is the answer. Not surprising. Okay. So that's how you do that, 35. Okay. So let's move on to (1.2). The poll is up. These are pretty easy. Maybe I'll give you guys 15 seconds to answer these. Guys are slow to respond. I don't know if everyone's in a position where they can be clicking. Yeah, so again, everyone looks pretty certain on this one. So I'm seeing everyone choosing the same answer. Still 3 people left to vote, but we're closing in 5 seconds. And let's end there. So as you can see, I just shared the poll with you. 100% believe that the answer is C. Let's actually do that. So again, we're using PEMDAS, which tells us that we should do what's inside the parentheses first. And then once we're inside the parentheses, we're going to do what's inside the parentheses first. So the first thing we're going to do here is calculate what's inside the first pair of parentheses, 7 minus 5. Calculates what's inside the second pair of parentheses, 20 minus 19. We're still working inside the parentheses. So inside now we have to do the exponentiation first. And then the addition. Now we have a multiplication here, as well as an addition. According to PEMDAS, the multiplication gets done first. So that would give us 15. And then adding those together, I get 29. So the answer choice is C. Okay. Okay, so I launched a new poll for 1.3. Everyone get your answers in. Try to do it a little bit quicker this time. Excuse me. Good. My nose is a little runny today. We finally have some disagreement. Okay, it's getting a little bit more exciting now. So there are 3 options. Okay, now we have some excitement. I'm closing the polling in 5 seconds, about 4 people left to vote. Okay, and we'll stop right there. So now you can see there is some disagreement here. We have 80% believing the answer is A, 13% believing it's B, and 7% believing it's E, which means none of the above. So let's actually see. Now, it's unfortunate that you guys can't see the polling while it's actually going on. I guess they do that because they don't want your answer to be influenced by what you see everyone else picking. But on my screen, it's really fun because I see the bars moving up and down, and it's like a race. And it was okay. I'm getting ahead of myself. Okay, so most people believe it's A. Let's actually see what it is. Again, we're doing PEMDAS. So we're going to be focusing on what's inside the parentheses first. Inside the first pair of parentheses, you have a bunch of operations, right? So again, we're doing PEMDAS. So inside, maybe have someone chime in on this one. Anyone care to speak up on how you'd compute the inside?
Maybe do the
Wouldn't
first.
you start? Oh, sorry.
Oh, go ahead.
Wouldn't you start off by doing the 4 minus 2, and then so you would get 2 from that, and then you would do the 8 squared.
So you start by doing what's in the parentheses?
Yeah.
Okay.
Now you do the exponents.
So the 8 gets exponentiated. Then
Square 3.
yeah, that's a separate thing. Okay, so the first one, 2 divided by 2 plus 64.
You divide the 2's and then you add it to 64.
So that's 65 minus 9, which is 56. It's 8. Okay. Maybe without launching the poll, someone can tell me what 1.4 is.
1.
How do you do that?
So you would start with the 3 divided by -3, and to get rid of, the 3 divided by 1/3, and to get rid of that, you'd have to multiply by 3. So you'd get 9 minus 9 plus 1, which is 1.
So you're going to focus on the 3. You're going to keep change flip. So that's 3 over 1. So that would be 9 minus 9 because you do the multiplication first. And that's 0 plus 1. Did everyone think that answer is 1?
Yes, I did.
Okay. What about 1.5?
9.
Maybe I'll launch a quick poll here. Do you have some disagreement? Four people left to vote. Three people left to vote. And I'm going to stop in 5 seconds. So there are the results. So it's split between B and C. 88% believing the answer is C and 13% believing the answer is B. Okay. So again, we're following PEMDAS. So which one is it? Anyone want to chime in and tell me how they think of this?
Sure, I can do it.
Mm-hmm.
So you got to do parentheses first. So that's 3. But when you want to do multiplication and division, you want to look over reading left to right. So you first want to do 6 divided by 2, and that's how you get 3. And then it's 3 times 3, so that's 9.
That is correct. And that is often something that's misunderstood by PEMDAS. So these last two, actually a polling on the second one, but the last two were among, and the last two, these two have in common 1.4 and 1.5, as well as the meme that I put at the end of the quiz. Where was it? There was a meme I put at the end of the quiz with like the Naruto universe. So this question here as well, 8 divided by 2 times 2 plus 2 is very similar to the example that we just did, the 6 divided by 2 times 1 plus 2. But what these guys have in common was that very recently, and that last example you would have seen me do in class as well, because very recently it was one of those, this was in the last fall, I think, was one of those break the internet problem, people disowning their family because they disagree on the answer. A lot of people thought the answer was 1. A lot of people thought the answer is 9. And there was all this disagreement and, people were arguing about it. But the thing that people often forget when it comes to PEMDAS, and what I hinted to at before, is that multiplication and division, as well as addition and subtraction, these guys have the same priority. Which means if both of them occur, you actually do it from left to right. So you perform left to right if both occur with no parentheses. Okay, so a lot of people read PEMDAS and they think multiplication comes before division, and that's not how it works. It actually works in the sense that if you have both multiplication and division, then you read from left to right. Whoever's on the left, you do that one first. Okay, so that's the little rule about PEMDAS that people often forget, and that's what causes all this disagreement. And I just wanted you guys to know. Now, in general, when I write things down on the board, you probably won't ever be in this situation where you're never going to be sure what I'm talking about, because if it's vague, I will put parentheses around stuff to let you know what I'm doing first. However, it's very important that you understand PEMDAS for a few reasons. One, it's good training to just know how to know about a mathematical rule and follow that rule. So that's a skill in and of itself that surprisingly a lot of people aren't really great at. And two, if you are trying to plug something into your calculator to compute something, right? So you're not going to use that on a quiz, but if you're working on the homework or something and you're plugging stuff into your calculator is going to follow PEMDAS. So you'll end up getting the wrong answer if you don't know how to enter things properly. So there are a couple of reasons why you need to know that. And I believe, was someone raising their hand?
Yeah, Professor. Sorry.
Yeah.
It was a quick question about a past problem that you just did, maybe like 2. I think it was number 4. You probably answered it. So you flipped.
Is it 1.4?
Yes.
Yeah.
So you flipped it because it has the same numerator as a denominator, right?
No, because that's the rule of division. The rule for division is if you have one fraction and you're dividing by another fraction, the rule is to flip the second fraction and multiply.
Got it. All right. Thank you so
So
much.
that's what I had here. So the 1/3 is the second fraction. So I have to flip it upside down and multiply.
All right. So it was because of a rule. It wasn't because of a similarity.
Yeah, no, that was a general rule that was being applied.
Okay. All right. Thank you so much.
So it has nothing to do with, in particular, that there were both 3s there or anything like that. Okay. It's once you have it divided by a fraction, it really means flipping and multiplying the fraction.
All right. Thank you, sir.
All right. Yeah, moving on. All right, suppose you wanted to evaluate this expression. What operation would be your first step? Would you first do an addition, subtraction, multiplication, division, or exponentiation? Go, someone just tell me. I'm not going to do a poll for this.
Division.
Right, so according to PEMDAS, you would first look in the parentheses. First, you look inside here, and inside there, you have the operations of addition and division. And according to PEMDAS, division comes before addition. So division is the first thing you would do if you saw that. What order is this done in? Q3.
Parentheses, division, multiplication, and subtraction.
Right, so you first do the parentheses. So that would be computing here. So now you have the division would come next because you have division and multiplication. The multiplication would come after that. And then the subtraction would come after that. So that's PDMS, PDMS. Okay, how do we multiply 2 fractions? A over B times C over D. What is the option here?
C.
Hello?
C.
Is it me or is the audio on that not great?
think they said C.
It's because of her AirPods. It makes it sound robotic sometimes.
Oh, okay. I just wanted to make sure it wasn't on my end. Okay. So she said C. That is correct. That's the rule. So if you have A divided by B and you're multiplying by C divided by D, you just multiply straight across. Only things that are in the numerator stay in the numerator, and things that are in the denominator stay in the denominator. What about this one? 4.2.
None of the above.
None of the above? Why? What's the rule?
It's that it would
If
go
I have A
across.
over
So
B plus or minus C over D, that is what?
it would be A times D plus or minus C times B all over B times D.
Yes, that's the rule. And none of those are the rule. So yeah. This one?
None of the above.
Well, what's the rule?
You have to take the reciprocal of the second fraction and multiply.
Right, so that's the rule. It should be AD divided by BC. And that's none of them. What is the LCD of these three numbers?
$90.
Maybe tell me, how do you find that? So the LCD, what is that? This is basically equal to the LCM of the denominators, as in least common multiple. Right? So how do you find the LCM? Maybe someone can tell me how to do that. How do you go about finding them? Give me a strategy.
You could like break each number down. So like for 15, you could do like 5 times 3, and for 18, then like 9 times 2. But you could break down the 9 into 3 times 3 times 2, and then like the other number was.
Right, so to find the LCM, the first step is to find what you're describing is called the prime factorization of each number. So there's a very important theorem in mathematics that says every number has a unique prime factorization. So if two numbers are distinct, you can write them distinctly as a product of unique primes, not counting one. It's one of the main reasons why one is not considered a prime number, so that we can have that nice theorem. So every number, every integer, you will be able to break down as a multiplication of prime numbers. So for example, 15 is 3 times 5. 3 and 5 are both prime numbers. Okay, so once you find the prime factorization of each number, what do you do? The LCM is, how would you describe the LCM after you did the breakdown that you described?
Is it like the highest exponent? Like you take the largest numbers and like take the highest numbers with the highest exponents?
So it's the product of all the primes that appear, product of all primes that appear raised to the highest exponent to which they appear. right? So if I'm looking at 115, 118, 130, so if I'm looking at 1 over 15, 1 over 18, 1 over 30. So what I need to do is find the LCM of 15, 18, and 30. So basically what I'm going to do is I'm first going to write 15 as a product of primes, 3 times 5. Going to write 18 as a product of primes. So this is 2 times 9, which is equal to 2 times 3 squared. And 30, I'm going to write as a product of primes. I can do this as 2 times 15, which is 2 times 3 times 5. Right? So now the primes that appear, well, the prime 2, the prime 3, and the prime 5. So this means my LCM is going to be 2 times 3 times 5. Oh, there's someone trying to get in the room here. And now I look for the highest power to which they appear. So if I look at all the 3's, the highest power of 3 is 2. If I look at all the 2's, of course, if the powers don't appear here, it means there is a 1. So the highest power of 3 that appears is a 2. The highest power of 2 that appears is a 1. The highest power of 5 that appears is also a 1. So my LCM, which in this case ends up being the LCD, is going to be 2 times 9 times 5, which is 90. So this is the LCD of the fractions.
Professor,
Yes.
if we were to like write it out and you had to see our work and we did it a different way, would you penalize us for doing it a different way?
In general, no. If your way makes sense, it'll be fine. What's another way?
I usually guess and check, so I'll take the largest denominator and then like take my choices and then kind of just go from there and guess and check. It's always worked in the past. Like this way kind of just confuses me. So I just want to make sure.
Yeah, so there are a couple things. Guess and check. It's hard to actually write that down. And 2, it's not very systematic. It means the numbers can get large to the point where guess and check won't work. But in general, I don't mind with guess and check. After this quiz, I'm not ever going to really ask you to specifically find an LCD. This is just something you need to know to do other things. And so the work behind this is usually hidden in the problems anyway. So in this case, I don't think that's a big a deal. But whenever you have a method of guess and check for anything, I do recommend that you know a systematic way of doing things as well. Another alternative is to just write out all the multiples. And pick the smallest common one. So if I look at, what were the numbers? 15, 18, and 30. So multiples of 15, multiples of 18, multiples of 30. Right, so you can actually write these guys out. Well, if I take 15, well, this is just going to be 15. I can multiply that by 2, and I would get 30. Multiply by 3, I get 45. Multiply by 4, I would get 60, then 75, then 90, then 105, dot, dot, dot. If I write down the multiples of 18, that's 18. That would be, what's the next one? 39. Then what's the next one? not 39. 36. What's the next one? Hello?
54.
Then?
$72.
Then?
90.
Then? All right, this one's 30, 60, 90, 120, etc. You'll notice that 90 is something that's in common, and it's the first thing that they all have in common. Now, there will be more things in common moving forward. In fact, the multiples of 90 are going to be the things that are in common, but you'll see that 90 is the first thing in common. So that's an alternative strategy. Now, of course, you can do some guess and check, but that's one's harder to write down. And if the numbers are sufficiently complicated, that can backfire on you. But in general, guess and check is not actually a bad thing to do. There are going to be times when I recommend the guess and check method for certain things. For example, when factoring quadratics, which you'll see in lectures soon. There's something more strategic called the AC method, but pretty much in every instance where we'll use the AC method, I'm actually going to recommend a guess and check method. That works most of the time. And it's often quicker. What about this one? So this is when you're finding the LCD, where you essentially have the same base. Right? So it's x to a power, x to another power, x to another power. How do you find the LCD?
The LCD is based off of the largest exponent, so it would just be equal to x over 7.
Right,
X
so
to
it's
the
based to
7th.
the largest exponent.
Would that only, like, you wouldn't do the method we just did before because it's an exponent?
No, in fact, the method here, you can think of it as the same thing. It's kind of like the breakdown for one was x, and the breakdown for the other one was x to the 5th, and the breakdown for the other one was x to the 7th. It's the same prime number. You can think of x as the prime number.
Like, I just got it wrong because, like, I did, like, 1 times 5 times 7 because I was, like, thinking of, like, what we just
Yeah,
did.
so the LCD is not always the multiplication of the numbers.
Mhm.
The LCD is only the multiplication if they don't have any prime factors in common.
Oh, okay.
So if I had a number that was 2 times 3, let's say it's 6, and I had another number that's 5 times 7, no prime factors in common, the LCD just ends up being the multiplication of all of them. Right, so if my A was this and my B was that, then the LCD of A, B is just, because you'll end up multiplying all the prime numbers that appear, but everybody appears exactly one time. So you end up just multiplying the two numbers. So LC, or more specifically, LCM equals product of all numbers if they have no prime factors in common. Otherwise, the above strategy is what you would use. So using the above strategy, it's like our prime factors, the x was the prime factors. You had x to this power, x to this power, x to that power. You take one of the bases that appear, and then you just take the highest power. So in this case, that is just going to be x to the 7th. Sylvester, you're raising your hand?
Yes, I had a quick question about
Yeah.
this. So let's say you had different primes, right? Let's say there was A, it didn't have an exponent, and then you had B to the 5th, and then you had, let's say, C to the 7th. How would you solve that? Or is
So
that,
these are three different numbers.
yeah.
So it's A is one number.
Right, and then you have B to the 5th, and then C to the 7th. And
Yeah,
it's,
then the LCM is just a product. You would just multiply them.
oh, so you just it's the product is listed like that. You just list.
Assuming A is not the same as B and not the same as C.
Okay, so let's say
Yeah,
like
so if the bases aren't the same, it's just the product.
okay, got it. So let's say on a we come across a question like that, we would list the answer like that.
Yeah.
Okay.
And I believe there's another example that would actually bring that home a little bit more. I believe the next example. Yeah, so here were two fractions with A, B's, and C's.
Sorry, I jumped ahead.
No, that's fine, right? So now, and this is why the strategy is very important, because yeah, if you have numbers like I tell you 15 and 30 and 55, right? Yeah, because there's specific numbers, you can do the guess and check very efficiently as if the numbers are small enough. But what if you have expressions, right? So it's an algebraic expression. You don't really know what the numbers are. How do you now figure out what the LCD is? You see what I'm saying? So now it's like, I don't know what 9a to the 4th, b to the 7th, c to the 8th is. That's just some number. It could be 15. It could be something else. I don't know, right? How do I find the LCD of these two? And the idea is sort of the same. You think of the bases as the prime factors that make up the number, and you just take the highest powers that appear, right? So maybe someone who thinks they have this concept can walk me through this. How do you actually go about doing this? So the two numbers, we have 9a to the 4, b to the 7, c to the 8th, and 21a squared, b to the 5th, c to the 6th. Now I want to find their prime factorization. What would those be? What is the prime factorization of the first one?
Is it 3?
3.
We're walking through like the whole thing?
Yeah, just tell me the prime factorization of the first number.
Okay, so it's 3 squared. And
Yeah.
then A4, B7, C8.
Right. So with the variables, you don't know what they are. You can't really do anything, so you just leave them alone. But the coefficient is a number that could be broken down further. What about the first one? The second one, the 21 blah, blah, blah.
7 and 3, and then A squared, B.
So it's 3 times
5.
7 times A squared times B to the 5th times C to the 6th.
Yes.
So now, when you see the primes that appear, the prime number 3 appears, the prime number 7 appears, A appears, B appears, C appears. So this means that the LCD is going to be, we're going to take the product of all of these guys. And I'm going to raise to the, someone's unmuted. Okay, got it. Okay, so what is the highest powers that appear? For 3?
Squared.
Right, a squared. For the 7?
It's just 1 7.
There's 1. What about the A?
4.
What about the B?
7.
And the C?
8.
8. So it turns out that this is 9 times 7, which is 63, A to the 4th, B to the 7th, C to the 8. And that looks like the first one. Okay. Any questions on that? So that would actually be the LCD of these two fractions. Right? So when it comes to strategies, I get that guess and check is a thing that works. You do want to know standard procedures though, because when you're in an unfamiliar situation, that's what helps you. So I went over PEMDAS. I took the time to go over PEMDAS and a lot of the rules of adding fractions and all that stuff. And the reason is because, yeah, you might know a quick trick in your head to do it with numbers, but when you have variables in play, things get a little bit more complicated, and you really should fall back on the principles that you've established before. When I'm in an unfamiliar situation that I don't know how to guess and check, how do I actually get to the answer? What is the procedure to go from A to B to actually figure things out, right? So learning things like PEMDAS very well, learning things like how to find an LCD very well, when you get into an unfamiliar situation, it's easy for you to actually pick up the pieces and know, oh, well, this is a problem I've never really seen before, but based on these principles that I know, I should do this first, this second, this third. And then you can get the answer like that. And algebra is kind of built up just like this, and pre-calc and a lot of things afterwards are built up just like this. You create the foundational principles, you learn how things work in the simple case, and then you start to extrapolate that to more complicated and more complicated cases. And you can often think of complicated problems as just little simpler problems that you know how to deal with one and by one. So once you know the principle behind how to find an LCD, you can find an LCD of any complicated looking expression. You just find all the unique bases that appear, pick out the highest powers to which they appear, multiply them together. Once you know that, you're golden. Yeah, so hopefully that illustrated more as along the lines as well of as to what Sylvester's question was, but let's move on. Okay, how do we express this in interval notation? How would the first one be expressed? S less than or equal to -1. When does our class end? It's 12:45, right? Okay,
Yeah.
what about the x less than or equal to -1? How do you express that?
So it'll be parentheses, negative infinity for the x. Then you have -1. And since there's that equal or less than, you put a bracket back of the
Right.
one, -1.
Right, and for this part?
Parentheses 2.
Yeah.
Comma. And you have 3 and bracket.
And this one?
Parentheses infinity, right? And then 5 and parentheses.
No, that one's a little bit off.
The last one, you want to flip the 5 and the infinity.
Right, you do them in increasing order, yeah?
Sorry.
So it goes from 5 to infinity. And so now when you see or, that translates to the union symbol in sets. And it's an inclusive or. So it's one or the other or both. And so there's another thing that means the exclusive or, where you put a little dot over the U. But yeah, so now we're just going to write all these things down that you figured out individually and put U's connecting them. And that looks like the first option. Okay, how would you express this that you see on the number line in red? Suppose that's the solution to a problem.
It would be the parenthesis negative infinity and -2 parenthesis.
Mm-hmm. And there's only one that starts like that. So it's probably this. Does everything else work out?
Yeah.
Yeah. So this part here is the negative infinity to 2 to -2 parenthesis. This part here, because there's a hole in the middle at 0, so I have to stop. It includes the -1, but does not include the 0. And then this part here, going onwards, is from 0 to infinity. And because you can be in any of these regions, you can be in the first one or the second one or the third one. Those are all solution spaces. You end up with connecting them with unions.
Because
I have a question. Oh, sorry.
Yes.
Sorry.
You can go ahead.
Okay, thank you. Because the 4 is the -4 is a shaded circle, that means it is included in the negative infinity negative.
Yes.
Right? Okay.
Yeah. So in fact, you could break this down to negative infinity, comma, -4, close parentheses, union, -4 to -2. But because this, it's contained in both. It's contained in both. So you can just actually go over it. Right? There's no need to isolate the 4. Technically speaking, though, that would still be correct. But it's not one of the answer choices. So I just put that dot there to see if I could fool anyone in picking this choice, but I didn't. So yeah, the 4 was included. So you can just think of it as the 4 is already in here. At the -4. So very good. Okay, what was the other question?
That was it. I was just going to ask the thing about the brackets, like the -4 and then the union for -4 to -2.
Yeah, because it's in both of them, you can just combine them. You can just stitch them together. Yeah. In fact, if it was in either one, you could stitch them together. So even if you had like -infinity to -4, it's included here and you union it with something else that's not included, you could actually combine that as well. Right? Because 4 is a member of both of these sets. They have the same members. Yeah. So yeah, that was fine. Problem 7, another important thing here, finding domains. So what would go into you trying to find the domain of this guy? What's the rule for the domain of the square root function? Hello?
You can't have a square root of 0.
You can have a square root of 0. Square root of 0 is 0. So what is the concept of the domain? When I say domain, what am I talking about?
You're talking about the range of x values.
Well, I don't want to use the phrase range because that often
Yeah,
refers
true.
to,
True. Yeah. Not range, but it's the
let's call it set
space.
of, how would you describe it?
The set of uh, all x values, I guess.
Well, no,
Because
because you could just say negative infinity to infinity for everything, anything like that.
true. You could of
How you want to think
like
about it is like possible
okay, yeah, that makes
input
sense.
values, right? What is possible for us? Possible means gives a real number answer. So it gives you an answer that it's on the number line. So for us, complex numbers aren't possible. And that should probably give you a hint if any of you know what complex numbers are. So what are the possible values I can plug into a square root and it gives me some real number?
It should start at 1, right? If it's a square root, because
No, you can take a square root of a half.
true.
You can take a square root of a quarter.
It can't be negative.
It can be negative. Another way to write that, tell me what the possible ones are.
All positive numbers.
You're missing someone.
And 0.
It includes 0. So x needs to be greater than or equal to 0. Or your x must be a member of this set. So for us, you can take the square root of 0, that is included. So pretty much whenever you see a square root, or this is true for even roots as well. For odd roots, actually anything will work, both positives and negatives. But for evens, that doesn't work. So now, pretty much what you have to do here is you have to worry about that requirement for each of these guys. So for this part, what do you need to be true? For what's under the square root to work, what do we need?
X minus 1 to be greater than or equal to 0.
So this means that your x should be greater than or equal to 0, right? So that x greater than or equal to 1. So we need this set to be true. Now, what about for the other part? Maybe I'll put that in blue. So for this part, what would you need to get that to work?
Two minus x needs to be greater than 0, just like before, or
2 minus x should be greater than 0.
greater or equal.
Yeah, or equal.
Sorry.
Okay, so you need that your x should be less than or equal to 2. Now there's another consideration. This thing as a whole, right? So this brings us into the discussion on domains of, say, fractions. So if I have A over B are possible inputs, how would you describe the domain?
B has to be greater than 0.
No, because I can take a 2 divided by a negative 3. That's a real number.
You can't equal 0.
You can't equal 0. And B needs to make sense otherwise. Right? So up here, what we need here, because it's a fraction, we need that the radical 2 minus x cannot be 0, but radical 2 minus x works otherwise. I know what it takes for it to work otherwise. My x needs to be less than or equal to 2. So what would cause this to be equal to 0?
2.
Right, if your x is 2 specifically, I need my x to not be 2. Right? So now what you worry about is you take all of these guys into consideration. And you look at the overlap. Of these requirements. So what does that mean? So on a number line, if I have that, I have my 1 and my 2. I know that I can be equal to 1. So for the first one, I can be equal to 1. And I can be anything bigger. For the second one, the blue requirement is that I am equal to 2 or less. And then the red requirement, and maybe I should move this. And the red requirement says I can be anything except 2. So the 2 is unshaded, but I can be anything to the right or to the left, right? So now what you want to do is you want to find the overlap of all these scenarios, right? So when it comes to find the domain of a function, especially when it's complicated, you have to break it in pieces. And I gave you domain rules for all these individual pieces, but when you put them together in a whole, you need to make sure all the individual pieces work. And then when you put them together, that new whole also works. So for example, for the 1 over the radical of 2 minus x, I had to make sure that the radical of 2 minus x works. And when I put it in a fraction, that also works. So that includes me worrying about 2 minus x being greater than or equal to 0. But at the same time, because it's in the denominator, it cannot be equal to 0. So I only get strictly greater than 2, strictly less than 2. So if I look at the overlap, if I look at the overlap, which I'm going to shade here in white, it's that region there. Notice that where all 3 colors are present, it's going to be greater than or equal to 1, but strictly less than 2. So that gives you this option here. Any questions on that? Okay, so that's how you go about finding domain. First, you should know the domain of individual things. How do you find the domain of a fraction? How do you find the domain of a radical that's an even radical? How do you find the domain of a radical that's an odd radical? Later on, we're going to talk about logarithms and exponentials as well. What's the domain of a logarithm? What's the domain of an exponential? What's the domain? You're going to learn about several different kinds of functions. You need to know where they work. What are the possible input values? And once you know the pieces for the individual functions, if I bring up a function by combining all these individual pieces, you need to know how to identify the individual pieces and what their needs are, and then you find the overlap. What region of the real number line fulfills all the requirements at the same time? And as you can see here, it's only the set between 1 and 2, including 1, but not including 2. With that being said, maybe someone, to make sure that we get this concept, someone can walk me through this one. What are the considerations?
We should probably set x minus 1 well, equal to 0, right? And then solve for x. And then whatever.
Right, so for denominator. So now you're looking at the denominator. Right, we need that x minus 1 is not equal to 0. So your x cannot be 1. Okay,
Yeah.
What else?
Well, we also need to do for the numerator, we need to, what was it? It's.
So this is the square root of x. We need.
Well, we know there can't be any negative if it's the square root of x, right?
Right, so tell me how you'd write down the need.
So.
Like I said here, something similar to saying x not equal 1. What's the requirement?
So, square root of x or not equal to, like, I don't know, like, I guess you could then show like the domain of negative numbers.
Remember, the domain is the set of possible values.
Okay.
Right, so you can't plug in a negative number, so that's not a possible value. We wrote this earlier. What's the domain of square root of x?
0 to infinity.
Right, but be specific on including 0. So you need x to be greater than or equal to 0. Right?
That makes sense. Yep.
So now those are all the requirements, right? So now you look for the overlap. So on a number line, there are two important numbers that showed up. So there's the x cannot be equal to 1. So one of the things on my number line is the number 1, and I know that I cannot be that thing. So I can be anything to the left or to the right of 1, not including 1. Another requirement is x must be greater than or equal to 0, which means there's also a 0 on my number line. I can be equal to that thing, but I can also be anything greater than that. Okay, describe to me what's the overlap here.
The overlap would be it's equal to 0 and it stops at 1.
Okay, so this is a part where they're both colors. It can be equal to 0, but it cannot 1, yeah?
And then it still cannot be 1, but start as 1 and then going on to infinity.
Right, or all of that, which is 1 to infinity. And then, of course, you throw in that union. I can be either over here or over there, and it'll both work. So I look for which one looks like that. That's A. Okay, so are we getting it? Are we feeling a little bit more comfortable?
Yeah, it makes a lot of sense.
But of course, again, the important thing is to always, and this is a general principle that I'm going to keep coming back to, go back to the basics, the foundational principles, right? Know what it is, what it means to find the domain of the individual, basic, very simple elements, like a square root of x, like a random fraction, like something like that. What does it mean to find the domain of that? Because when you have something more complicated, like a combination of these things, like what we had here, it just comes down to you breaking it down to the simple components, figuring out how to deal with those simple components, then putting it all together so that everyone's satisfied. Okay.
Hey, Professor, sorry.
Yes.
Can you go back just for maybe 2 seconds to that last, just for a quick second? All right, thank you so much.
Okay.
That's fine, thank you. Sorry about that.
All right, so difference quotient. How do we do that? And I actually gave you the difference quotient here. So this is f of x plus h minus f of x all over h. And we actually did this on the very first day. We looked at how to do the difference quotient. So maybe someone can remind me how we're gonna plug this in.
You put x plus h into all the x's in the original function.
Yeah.
And then you subtract the function after you do that. And then you put it all over h.
Like that?
Yeah, but I would put I usually put parentheses.
Where?
I would do it, okay, around the x plus h minus the 2x plus h.
Like that?
And then, yes. And then I do it around the x squared and negative 2x.
Right.
Mm-hmm.
So that is what the correct first step should look like. Okay. All right. So now it's all about simplifying this because that's not any of the answer choices. So, and the problem says simplify. So let's actually look at simplifying this. So the first one, x plus h squared, that's just x squared plus h squared, yeah?
No, it's x squared plus 2xh plus
No.
h.
Okay.
Oh.
So good. So it's x squared plus 2xh plus h squared, right? So that what I did was very legal. It was distributing a power across the sum, cannot do that. So here it's 2x minus 2h. Here it's minus x squared plus 2x. All right. Now what?
Combine like terms.
Okay, which are?
You would combine.
X squares die.
Yeah, cross out the x squares and then cross out the negative 2x and the positive 2x.
Mm-hmm.
And
Anything else?
I think that's it.
Okay, so now we have this. We have 2xh plus h squared minus 2h all over h. I can just cancel these h's right here, yeah?
No.
No.
No, very illegal. You do that and Jhevon comes to your house and throws the chalk eraser at you. Okay. What do we do here?
You have to factor the top.
Which is how?
You could take out an h, so it would just be h.
Now what?
Now you can cancel that h on the outside and the h at the bottom.
So that should be the answer. 2x plus h minus 2. Is that here anywhere? Yes. So that's that one. Here's the other one. Maybe someone can quickly walk me through this one.
I think I think the answer is B, but what you do is what I would first do. I would distribute the negative and then combine like terms.
Right, so now we combine the fourth powers. So that's 6c4. Combine the cubes, minus 7c cubed plus 5c cubed. And combine the 3 and the 1, so that's plus 4. Does that match with anyone? Yep. So that one was sort of creepy. Okay, so this one was just testing your general algebra skills. It's also the kind of problem that you always see those stories where a lot of people on the internet are arguing over what the answer is, or it's one of those things that kind of problems that stump people. But if you're very careful with the algebra, it's actually not so bad. So a bat and ball costs $3.50. The bat costs $3 more than the ball. What is the cost of the ball? Hello?
I guessed 50 cents, but I might be wrong.
Wouldn't it be if you have a bat that costs $3 more than a ball, you could place the ball as like X and then the bat would be 3X. So
Right.
you'd have
So
3 plus X. And so you'd have 2X plus 3.
We want the ball. So that's our algebra. So let X be the price of the ball. This means that X plus 3 is the price of the bat. So we know that ball plus bat equals 350. So this means that X plus 3 equals 350. So this means that your 2x plus 3 equals 350. And this means that 2 times x is equal to 50 cents. So this means that your x is actually equal to 25 cents. Right? Now, saying that 50 cents is a very common error. So when we say, oh, it's 3 more than that, and you hear 350, people just think, oh, it's 50 cents because it's just like, no, but if you think about it, if the ball costs 50 cents, 3 more than 50 cents is 350. And if you add them together, you actually get $4. You won't get $3.50. So it doesn't actually work. So the idea here, the trick, is to use algebra. Let X be the thing you're searching for, and you can actually work that out to be 25 cents, which means it's actually none of the above. It can be determined, but it was actually not shown. Right. So that's a very common one. I think the usual, you guys can even look it up. It's a very famous problem because it showed up on an entrance exam for a university or something like that, and everyone was surprised that so many people got it wrong. But it's usually $1.10 in the actual, in the real problem. So you can actually look up that problem. A ball and a bat cost $1.10. If the bat costs $1 more than the ball, how much does the ball cost? And a lot of people said 10 cents, but it was actually not 10 cents. Okay, so these guys were optional, which means you didn't technically need to know how to do these yet. So I'll just breeze through these very quickly. Once you watch the future lectures, you will get to know these things. A is an expression with 4 terms. You wish to factor it. What is the first thing you look for? Factor by grouping is what probably most people would think. However, it is GCF. GCF is always the first thing you look for. This is the greatest common factor. Whenever you want to factor anything at random, looking for the GCF is going to be the first thing you want to do. I do go into factoring in detail, so I talk about all the techniques that you'll need to know from factoring and how to apply them, when to do which one first, etc. So GCF is always first. You always look for a greatest common factor. Can anyone tell me what the union is very quickly? Does anyone know?
It means like and, or like including both.
Right, it means inclusive or, which means if A union B means it's in A, or it's in B, or it's in both. See, it's kind of like a collective of everyone. So what would that look like here?
In this one, it's the second answer from 1 through 8.
Right. Right, so that's the set of all things that are in A or B or both. That's what or means. Or union. Where are we? And this is intersection. So this is another one. And it's, this one is somewhat tricky, but I think a nice way to look at it is to actually graph everything. So of course, 0 is where it all starts, but no one can actually be at 0. So there was one set that was 0 to 1. Then there's another set that's 0 to 2. Then there's another set that's 0 to 3. And this keeps going, etc. Right? And I asked for the intersection. Intersection just means what is in all of them at the same time. So the intersection is what is in all the sets. You'll notice that every single set will include the set 0 to 1. If I said or, if I asked for the union would be 0 to infinity. And I'll leave you guys to think about that. This is a bonus problem, so I'm not going to spend too much time on it at this point. Oh, I actually answered that. I didn't remember I actually asked that. The union is what's in any set at the same time. Not at the same time, but what's in any set. All the numbers that you can find in any set at any given point will be everything, for everything greater than 0. And I'll provide a PDF of all of this. But the bonus point, like I said, you don't need to know that at this point anyway, but just for the sake of completeness. This one is a little rough, but the idea here is to factor. So this will be factor into x plus 1 times x plus 2 times x plus 4 now multiply and you flip. So on the top, I'm going to factor the x squared plus 6x plus 9. That actually factors into x plus 3 squared. And on the bottom, I'm going to factor the x squared plus 6x plus 8. I believe that factors into x plus 2, x plus 4. And now we cancel common terms. So everyone cancels. You just get 1 as the answer. And I believe that's it. Yeah, so this was one of the recent problems that broke the internet. This was the one I spoke about in class. And I didn't even create this meme, so just so you know, it was of a more larger interest. But yeah, we'll wrap it right there. We had some important concepts discussed this class, so that's good. And I like the interaction. Thank you guys for participating, but we'll stop there. I didn't post the videos for our last Zoom meeting because I had trouble with the editing, so hopefully I can get those out soon. But that being said, at this point, I think we will stop there. So thanks for joining. You have a lecture to watch today. I don't have the schedule in front of me, so I don't even remember which, but be sure to check the schedule in the syllabus and watch the lecture that you're supposed to watch today. And that's it for now. Thanks guys for joining. Again, if you have any questions, reach out to me in email. I'll answer your questions, but for now, we'll stop there. Okay, so take care, guys. Enjoy the rest of your day. Have a good week.
Thank you.
All right, you're welcome. And
Take care,
that's
everyone.
it. I'll see you guys in the next one. Ciao.